Hello everyone, thanks for tuning in. What you're looking at here is the new release of IBM Watson Studio Local, which was previously branded as Data Science Experience or DSX Local. If you are familiar with the public cloud version of Watson Studio, this is the on-prem light version of that. So instead of running on IBM Cloud, this version is installed in your own local cluster. With it, you get all the same data science tools like Spark, Jupyter Notebooks, and RStudio. To best demonstrate how to use Watson Studio Local, I will be going through a code pattern that creates and trains a machine learning model using Jupyter Notebooks and Python scripts. The code pattern is available on GitHub at github.com/IBM/model management on Watson Studio Local. The code pattern steps through a machine learning exercise where we start with a data set containing the numerous chemical properties of a large selection of wines, along with what classification or type each of the wines falls under. We then use pca-analysis for feature engineering to extract just two principal components that can be used to predict the classification for any of the wines. If you want to learn more about PCA and how this is done, you can check out the documented steps that are in the Jupyter Notebooks. Along with the notebooks, the GitHub repo contains all the assets you will need to complete the code pattern. If you go through the README, you will see links for how to install Watson Studio Local. You will also see the steps you'll need to complete the code pattern. It has a lot of screenshots and step-by-step instructions, all of which makes it pretty easy to follow. So let's get started. As you can see, I have Watson Studio Local installed and running. I've also cloned the GitHub repo to my local system. The first thing you need to know is that there are two personas. One is Watson Studio, where you do all of your setup and testing. And the other is Watson Machine Learning, which, as you'll see later, we'll use for deployment. So here we are in Watson Studio. The first step is to create a project and add in all of our assets. You can do this by clicking on the Add Project button, and then I'll name my project Demo PCA. Once created, we see the asset list, which currently shows 0 assets. Let's get started by loading our notebooks from the GitHub repo. Click on Notebooks, then the Create Notebook button, then use the URL option to load. We grab the URL from the README. Let's give it a name. And make sure we select Python 3 Spark 2, Spark version 2. Now let's do the same for our second notebook. Now let's add our scripts. Click on the scripts list, then use the Add Scripts button. For this, we can use the From File option and point to the scripts directory of our local repo. We can use the default name, make sure we select Python 3, then load it. And then let's do this for all 3 of our scripts. Finally, let's add our wine data set. This is a CSV file that was downloaded from the Kaggle data site. It can be found in the data directory of our local repo. Next, we need to create our model, which we do by executing our notebooks. Let's run the PCA features notebook first. Make sure we select Python 3 with Spark version 2. And as we step through this notebook, you can see that it takes the wine data set and transforms it, building a features file and a target file. These two files are now the input for the second notebook, which is called PCA modeling. So let's go ahead and run that one now. Here you can see it's using those two files to build and test and create the model. And here's where it saves off the model. So once complete, we can go to the data sets list and see the newly generated files. Just a quick note about why we have separated out the data processing steps and the model creation steps into two notebooks. The main reason is that it allows us in the future to just process any new wine data sets without having to build a new model. Once a model is built, it should in theory work for any new updates to our wine data set. So at this point, we are ready to save off our work. Anytime changes are made within Watson Studio, you will be reminded to commit and push your changes. So let's do that now. First we commit. And then we push. And when we push, we add a version tag. We'll call it version 1.0. Now it's time to create and deploy our project using Watson Machine Learning. We launch it by selecting the main menu. First, we need to create a project release by clicking on the Add Project Release button. Here we assign a new name. Then a route. This route name will appear in all the REST endpoints that we'll be generating for this release. We pick our source project, which is the project we just created. And we pick the right version tag. If you click on the Assets tab, you can see all the assets have been copied over. Now we need to deploy our newly created model as a web service. To do this, we click on the model, then click on the plus web service. Here we give it a name. You can see our route name has been added to the endpoint. Here we use the latest release. Select Python 3. Then we can also dedicate some resources to it. Let's go ahead and do that. And replicas can be set higher if we run into any scalability issues. Now let's deploy our scripts as jobs. We do this by selecting one of our 3 scripts from the asset list, then clicking on the plus job button. We add a name, used script run for job type, select Python 3, and we add v1 as a command line argument. This is very important. This version tag will be used as a file suffix so that we don't have to override our CSV files in the future if we bump up our model version. Let's go ahead and do the same steps for our other two scripts now. Now if you click on the Deployments tab, you'll see a list of our assets ready to be deployed. To deploy them, all we do is click on the Launch button located in the icon bar. For the model, we will need to explicitly enable it. And once deployed, it means that each of the assets is running and is callable via a REST API. Now would be a good time to go over what each of the scripts do. Feature engineering is simply the first notebook in script form. In fact, it was created by using the option output as a Python script from within the notebook. And as with the notebook, the output of the script is the creation of two CSV files needed by the next script, which is model scoring. This script takes the CSV files as inputs and passes them through the data model to generate the classifications for the wines. The classifications are stored in a new CSV file. The final script, extract and copy, is simply a batch script that calls feature engineering and then the model scoring script. This script basically eliminates the need to ever call the other two scripts individually. So now that all of our scripts and the model have been deployed, we need to modify our scripts to call the actual endpoints. So let's start by gathering all the information we need to make that happen. We'll need to get the endpoints for the model in the first two scripts. To get them, simply click on the name in the deployment list. Then use the copy icons to copy the data. We'll start with the deployment token. We only need to copy this once as it's the same for all of our assets. Let's paste that into our notepad. Then copy and paste our model endpoint. Then we can repeat this for our script endpoints. Once we have our values, let's go back into Watson Studio and make the changes to our scripts. The first script we're going to need to change is our model scoring script, which needs the endpoint of our deployed model. But this script requires CSV files as inputs, and those are generated by the feature engineering script. So let's run that script first. To run it, we can use the tools available in this window. First, we click on the Run configuration to add our command line parameter, which will be v1. Then we drag open the console screen, then click the Run button. Once it completes, we can verify it worked by clicking on the Datasets tab and see if we have our two CSV files with the v1 suffix. Now we can modify and run our model scoring script. Let's substitute in the auth token and our model endpoint. Let's save our changes, then run it just like we did our first script. To verify it worked, let's check if we generated our new scoring output v1 CSV file. Our last script to modify is our extract and score script. For this, we need the auth token again and the endpoints for both the model scoring script, which is the one we just ran, and also for the feature engineering script. Note that when we paste in the script endpoints, we remove the trigger from the path. Script endpoints have three values that can be specified. Trigger, which invokes the script, stop, and status. Our script code will add in this value when needed. To quickly recap what this script does, it invokes the feature engineering script, then requests status on it and waits for it to complete. It then invokes the model scoring script, and then it requests status on it and waits for it to complete. Let's go ahead and save our changes and run the script. As you can see, we get an error when running the model scoring script. This is actually to be expected because remember, we are invoking the deployed version of the scripts we set up in Watson Machine Learning. Those versions, specifically the model scoring script, doesn't have the model endpoint added yet. So the main purpose of running this here is to make sure we didn't have any syntax errors. So now that we have the auth token and endpoints added to our scripts, let's move those new versions of the scripts back up to Watson Machine Learning. As before, let's commit and push our changes. We'll call this version v2.0. Now let's go back to Watson Machine Learning and update our release to grab the changes to our scripts. We do this by clicking the update icon, select our source project, and select version v2.0. Now let's go to our master script, extract and score, and run it. If we go to the API tab, we see that v1 will be passed in as the default. If we go back to the overview tab and scroll to the bottom, we can see the option to run it. Once started, we can click here to view the logs. Once completed, we can go back out to the main dashboard and check out the status of any recent jobs. And here you can see the script we just ran, plus the other two scripts that were invoked. One last check to verify that everything worked correctly. Let's look at our data set list. As you can see, 3 new files have been created, all with the suffix v1. Features and targets were generated by our feature engineering script, and scoring output was generated by our model scoring script. So that concludes the demo. Hopefully that gave you a good overview of the Watson Studio Local suite of tools. If you want to dig deeper, I encourage you to install it yourself and go through the code pattern again on your own. Again, the code pattern can be found at github.com/IBM/model management on Watson Studio Local. Thanks for your time and have a great day.